So last time we have gone through these commands. Okay, I have seen all these commands, and in the next session we went through WC, okay, cut commands, and the translation command, okay, head command, tail command, and we have discussed about piping of the commands. Okay. So actually for the tr command and cut command we had to go to piping of the commands also, right? So we have discussed here. Okay. So today we are going to see some other commands, okay, grep, which is a pattern matching command. Okay. What is a pattern matching? Okay. Pattern matching is nothing but, okay, we have a particular word or a keyword, okay, to search in some hundreds of files. Okay, then what to do? Let's suppose I have 1000 BTQ scripts, okay, which I have written for loading to Teradata, or I have written some hundred of fast load scripts. Okay, so there are some hundreds of scripts, okay, and the DB has changed the database name or a table name. Okay, so now what I have to do, I have to open all the 100 BTQ scripts or all the 100 fast load script, and I have to change my database name if I have hard coded the database name in all the scripts, right? Let's suppose it is a table name otherwise. Okay, so table name anyway we will hard code in the scripts, and if I need to change all these database name table names in all these 200 files, okay, how much effort I need to make? Okay, so I have to open each and every file, I have to search for this pattern, and then I have to replace it with the new table name. Okay, like this I have to continue it for 200 files, right? So instead of that, okay, if we able to find in which files this table name is used, okay, then we will pick up only those 10 or 20 files and we can change it easily, right? So that is called a pattern matching. So we have a keyword to match, okay, in hundreds of files. Then we have a command called grep, okay, and a pattern, okay, which has to be searched. Okay, so I want to search this keyword 1 in all the files in my folder. Okay, so let's say start. So it will search for this one keyword in all the files in the directory. So there is no such file or directory. Okay, let's go to some other folder, our own folder where we have created our files. Okay, so this is my folder. Okay, grep 1 in all the files. See, now it is getting me the files which containing the keyword 1. In which files it is existing? In file 5 there is a 1, in file 7 there is a 1 in the first line, and there is another line also with the 1 keyword, and in file 9 also there are 2 lines with the keyword 1. Okay, so even though I have these many number of files, okay, I know in which files this pattern 1 is existing. In which files? In file 5, file 7 and file 9. So if I open these 3 files and if I can change this 1 to some other keyword, okay, that would be sufficient for me instead of going and opening all the files and search for it, right? So it makes my work easy because it has given me the list of files in which this pattern is existing. Okay, so this is how, okay, we can use grep command to find out any of the patterns. Let's suppose now I am searching for 2 in all the files. See, it is getting me wherever 2 keyword is existing in the files. How many times it is existing? All the details it is giving me. Okay, so within the grep we have some other options and other switches. Okay, let's see them. Yeah. Now I wanted to see all the files, okay, which are not having these type of keywords. Okay, I wanted to see, okay, which are not having, that means negative search for the keyword 2 in this directory to search in all the files. See, in all these files I'm getting these are negative results of this particular file. We don't have that keyword. See, in 14, 10, 11, 2, 3, which were not coming as the result of the grep. Okay? The rest of the lines are coming in the negative sets of the 2. Okay, like this, if you have a requirement that you have to find out all the files which should not contain this particular table name, okay, then you can go for a negative sets with a -v option. Okay, so this is one of the options with grep -v, which is a negative searching, okay, to find out in which the lines are not existing. Okay, we have one more switch called -c. Okay, and in the file -c. Okay, let me get for 1. See, in each file, how many number of occurrences are there? Okay, it's getting me 0 occurrences, and for file 9, it's getting me 12 occurrences. Let's see what is it. Cat file 9. No. It's taking much time. Okay, so to eliminate any of the long executing command, we can go for Control C to terminate that command, but even that Control C is not also working. Let's wait. Oh, stop. I open a new instance. So this is our folder 1. Okay, so okay, so this is how it is getting us the content. Okay, so what we have seen is grep Okay, so second, so this is the pattern I want to search, and I want to use a switch minus C to find out the count of occurrences, right? And then file 2. Okay, you can give star also to search in all the files, and if you know in which particular file it is existing, and if you want to know the count of the occurrences, okay, then you can go and give the particular file name also. Okay, whereas star is a wildcard which implies for all the files in the folder. Okay, you can replace the star with the particular file name if you know in which file you have to do the operation. Okay, so now what I wanted to do, I wanted to see the number of occurrences of the keyword second in the particular file 2. So I'm using a grep command to see the number of occurrences. See how many number of occurrences are there? Number 1. Right? So in the similar way, if you want to find out any of the occurrence, number of occurrences only, then you can go for minus C switch. Okay, and we have another switch called minus n, okay, which gives the line numbers of the file. Okay, so let us take one more file, okay, which has multiple lines. Okay, what is the content of file 6? Okay, file 6. Okay, so let's take file 6, which is having multiple lines. Now I wanted to find, okay, in which line number of the file my particular pattern is existing. Okay, let us search for 8. Okay, and use a switch called minus n, and on the file 6. See, it will give the pattern, the line content, and along with the line number. Okay, without using minus n switch, what it was giving, only the line, the content, okay, in which line this particular pattern is existing. But I wanted to see in which number of line in the file this particular pattern is existing. Okay, then we can go for a minus n switch so that it will display the line number also along with the content of the line. Okay, and sometimes, okay, we need only the file names, okay, in which this particular pattern is existing. Okay, in all the files I'm trying to search this pattern. Okay, I don't want to display the content, but I want to display only the file names in which this particular pattern is existing. Okay, then we can go for a minus L switch. See, if I don't use minus L, what would have happened? It would give all the file names and the content of that particular line in which it has the pattern, right? But now I just wanted to see the file name alone, so that it won't be repeated and it won't show the actual content of the particular pattern line. Okay, so it just give me, okay, in which files this particular file, this particular pattern is existing. So I can simply use this file name list for my further processing. Right? Like this, we can use grep without any switch, the file name or the wildcard star, so that it will give the pattern. And we have a minus V switch, okay, to do a negative search to find out the lines which are not containing this particular pattern. And we can use minus C to get the count of occurrences of this pattern in the files. Okay, and we have used minus N to see the line numbers also along with the actual lines. Okay, and then what we have seen, minus L, okay, where it will display only the file names, okay, without the content, so that we will get the distinct list of all the file names, okay, which containing this particular pattern. Okay, otherwise, if the particular pattern is existing 2 times in the file, we will get the name 2 times and we will have the content also displayed along with the file name. Okay, so to eliminate this, we can use minus L switch. Okay, as per the requirement, we can go for any of these particular switches. Okay, so this is about the grep command. Okay, this is called global regular expression printer. Okay, that is the full form of a grep command. Okay, and now let's see another command, compression. Okay, so this is also mostly used in real time, where we see very huge size file. Okay, we have to zip the file and keep it so that it will occupy less disk space, right? So let us try to compress a file with a gzip command. Okay, what is the command to compress? It is gzip. Gzip file name. Simple. And now see, the file 11 is having a default extension called .gz. That means it is compressed. Okay, file 11 is compressed now. Okay. How to see the long listing of the files along with the size? This is -L, right? And we have a timestamp basis sorting and the reverse basis sorting. So we can use ls minus lrt, okay, as a regular command to display the long list of the files, where you can see the size of the file also. See, file 11 in the zip format, in the compressed format, it is 3 bytes. Okay, so this column is size actually. Okay. Actually, the size gives in number of blocks. Okay, this is date. Sorry, this is the size column. Okay, we have 33, 60, 28 of there. That is the size column. So it gives in terms of blocks. So it has 57 blocks occupied. Okay, so if you see, file 9 is having 955 blocks occupied. Okay, let's try to compress it and see how difference it is giving in the terms of size. Let us zip it. Gzip file 9. Okay. Now if you see the long listing, okay, we should be observing the compression. See, it was 955 blocks, okay, before compression, and after compression it was occupying only 140 blocks. So how much reduction of disk space? It is almost 80%, right? So 80% disk space is compressed for the file 9. Okay, so if we have compressed file, we cannot see the content, right? If I give file9.gz to see the content, it won't get me the content because it is in compressed format. So normal cat command cannot understand it. See, it is in the compressed format and an unreadable format. Okay, so now what I need to do, I need to uncompress it. How to uncompress? G-unzip. Okay, some people call it as gunzip, okay, but it is G-unzip. Okay, so G-unzip file9.gz. Now if you see, the file got unzipped and it was occupying its own actual size. Okay, so when we are not using the file and the file is having very huge size up to 2 MB or 1.5 MB, okay, then we can keep it compressed so that we can accommodate other files also. And when we are using it, okay, when we are going to use this file again for our processing, we can unzip the file and we can use for further processing. Okay, so this is how we can compress the file and we can uncompress the file, okay, by using gzip command and unzip command. Okay, so now we'll see one more command, scd, sed. Okay, sed is a utility in Unix, okay, which is an advanced utility to do some pattern matchings and finding and replacing. Okay, so we mostly use this sed command to find and replace. Okay, in Windows it is easy. We can have a control H command okay, in the MS Word or MS Excel, and we can give the pattern to be replaced, and then with which pattern we have to replace, give an OK. It will find and replace all the particular patterns with the required pattern. Okay, but in Unix, okay, it is not a GUI based, so we have to use a command called SED to find and replace a particular pattern. Okay, we have seen grep. Grep is for what purpose? To display only the particular pattern, right? So let's suppose if I give this, it will give me in which files we have that particular pattern existing. Okay, now what I wanted to do, okay, wherever I see a ONE, okay, I wanted to have it as a capital ONE, so I want to replace it. Okay, Unix is very much case sensitive, so capital ONE and small ONE are entirely different. Okay, and in commands also, if you type in capital, it won't recognize that command because it is a case sensitive. Okay, the operating system itself is a case sensitive, so capital grep and small grep are different for it. Only it will identify small letters grep as a command. Sorry, grep. Okay, let us try the total command grep 1 install. See, it won't identify. Okay, but if I give within small letters, it will identify. Okay, let me look like this. Okay, here in Sequin, where it is Windows based utility again, so it is considering grep as a command here. Okay, but in normal Unix flavors, in Red Hat Linux, okay, in AX Linux, it won't accept any of the capital commands. Okay, it will clearly distinct the capital letters and small letters. Okay, so now what I wanted to do is, okay, I wanted to find wherever this one is existing, I want to replace it with capital ONE. Okay, so how I can do it? Okay, with the sed command. Okay, with grep command, just we can display the patterns, but with sed command we can replace it also if it is required. Okay, sed, okay, S is the switch to replace the patterns in SED. Yeah, just a moment. S is the switch, okay, and the pattern to be searched, pattern to be replaced in file. Which file we have? Well, file 5. Okay. Okay, so there are some variations. Let me just try one more time. Okay, sed, you have to use switch within the codes for replacing this one pattern with capital 1. Okay, and we have to use a P switch for the print option. Okay, S is to replace and P is for print. Okay, so these are some legacy commands where we have to use some legacy switches. Okay, so even though it prints on the monitor, we have to tell it explicitly to print on monitor. Okay, so to print on monitor also we have to use a switch called P and then the file name. See now, it has taken the content of the file 5 and it has replaced the small ONE with the capital ONE. Okay, so the S switch to be used within the quotes along with the pattern here. So this is how we can find and replace the particular pattern. Okay, and we can capture it in some other file. Okay, so here I'm just printing on the monitor, but you can capture this output into some other file and you can use this for further processing. Yeah, how we can capture it? Okay, let us try one more time for another pattern. Okay, I am changing TWO to capital TWO. I wanted to print it, and then input is file 5. So let's try to capture this in file 55. So it didn't display anything for me on the monitor because I have captured the output by overriding the output stream, okay, from default monitor to the file 55. So the content is captured in file 55. So let's try to see the content of file 55. See, the output of the set command, wherever it has converted small 2 to capital 2, is captured into file 55, and now we have the resultant file in some separate place stored so that I can use this file for further processing. Okay. So like this, we can use std command for doing find and replace. Okay, so it is not limited to find and replace. Okay, but in real time, std is being used for find and replace. But there are so many other other functionalities where we can execute with the std utility. Okay, std is not a command actually. std is an utility. It is a package itself, okay, where it has so many other purposes and other switches where you can explore it with the man command and get it. But generally, okay, std is used to find and replace in the real time and in the real work. Okay, so it is also similar case. Okay, wherever you want to change a particular table name in hundreds of scripts, okay, you no need to search for this pattern first of all. Okay, you can directly use set command. Okay, if you know the set command to replace it, okay, then you can find the command and replace the table name also at the same time. Okay, if you don't know the set command, you will go with the grep command, right? You will go with the grep command, pattern, star, then you will get the list of the files, and then you will open each and every file and you will replacing it. So it is a better way of doing the replace, okay, when comparing it with when you open all the 100 files and search for the pattern. Okay, so it is better than that. But if you know the set command also, okay, it is more better. Okay, and then this is the best way of replacing it. It is replacing, okay, at the same time when it is finding the pattern. Okay, so while grep is only giving you the matched files, you have to go and search for all these files and do it manually. But with the set command, okay, in all the files, it will replace the content at the same time when it finds the pattern. So it is the better way, more better way of, okay, finding and replacing. Okay, so this is how, okay, you can use grep. Okay, and then let's see file permissions. It is also some frequently used question. Okay, when we have ls minus lrt, we are getting a long listing of the files, right? In this first part of the long list is the file permissions, okay, where we have R is for read, W is for write, okay, and there is one more dash here, right? This dash is to represent execute permission. Okay, when we have execute permission, it will display as X. Okay, so RWX. Okay. So let us try to explain it here. Okay, we have read permission, write permission, and execute permission. Okay, and in the binary language, okay, we can say it is 2 power, okay, X is 2 power 0. That means 2 power 0 is nothing but 1, right? So whichever is having power 0, that would be 1. And here it is 2 power 1. W is for 2 power 1. That means 2 a single time. That is 2. And the R is called 2 power 2. That means 2 times. 2 into 2. That is 4. Okay. So we have to remember these permissions in terms of this binary digits. Okay. X execution is always 1. Okay, W is always 2, R is always 4. So how we have determined this? 2 power 0, 2 power 1, 2 power 2. Right? And if you observe here, okay, RWX is there, and still we have so many dashes, right? What are those? Okay, the first three terms RWX represents the permissions given for the owner. Okay, owner permissions. Who is owner? Who is creating this file? Okay, that person is called a owner, and owner would have default these permissions in my system. Okay, it can also be altered. How a default permissions to be given to the user, and how the default permissions to be given to the groups, and how the permissions to be given to others. So there are three parties here, okay, who can use this file, and those people are segregated in three parts. First one is called owner, second one is called group. Okay, that means if you are aligned to a group and if there are 10 other people in the same group, okay, we can call all other 9 people as group. Okay, so if you have joined in a team of 10 people, okay, you are the owner if you create any file, and whatever file you create, okay, all other 9 people in your group will also have some accesses, okay, defined by the administrator. Okay, so the second octant, the second 3 dashes represent the permissions for the groups, okay, and then others. Okay, the last 3 are for others, RW. Here you see R dash dash. That means if you find out this file 2, okay, what all permissions these people are having, the owner has read and write, okay, no execute permission, and the group is having only read access, so group cannot write anything in this file, and others also have read access, but they cannot change the file content. Right? So by seeing this dashes and this RWXs, okay, you can determine which group or which people, okay, who has what accesses on this particular file. Okay, so now how to change these permissions? Okay, once it has the default permissions obtained, how to change these permissions? Okay, to change these permissions, we have a command called change mode. Okay, chmod, change mode. Okay, we can give the permissions in terms of numbers. So now currently it is having read and write for owners, read for groups, read for others. Okay, now what I wanted to do, okay, I wanted to provide the RWX for the owner, that means along with the execute permission, and for the second octant I just wanted to give read and write for the group and only read for others. Okay, so my question is, okay, how to provide, okay, all permissions to owner, read and write permissions for group, only read to the others. So this is what my requirement. Okay, for the file 2 I wanted to give permissions in this way. So how to do? Okay, if I wanted to give all permissions, then what it is? X, W and R. Okay, if you sum in terms of numbers, okay, how much it would get? 1 plus 2 plus 4. So how much it is? 7. Right? So we'll call this permission as 7. If you wanted to get read, write, X, all the permissions for the owner, okay, then in the first octant we have to give a 7. Okay, for the owner we have calculated it. Okay. For the group, what are the permissions we want to give? Read and write. Okay, just sum up this read and write numbers. 4 plus 2, how much it is? 6. Okay, so the second octant should be 6, so that I will get read and write permissions for the group. Okay, and now what is the third octant for others? For others he is asking only the read access. So for only read access it is only 4. Okay, 4. Okay, so at the third octant if I give 4, it will imply for the others. Okay, so it is chmod 764. 7 is for the owner, all the permissions. 6 is read and write. Okay, and it is at the second place, so it implies to the group. And 4 is for read access and it is in the third place, so it is implied for the others. 764 for file 2. Okay, so now what we are going to see is the permission should be like this: rwx, and then rw dash, and then r dash dash for the file 2. Okay, that means read write x, 3 options, okay, which we have represented with the number 7, and only read write, which we have represented with the number 6. Okay, 4 plus 2, and then only r, which we have the 4 for file 2. So this is how, okay, it should look if it executes. Not sure. Okay. All are there, right? Okay. Okay, so chmod got executed, and let us see the permissions. Now see, rwx, that means 1 plus 2 plus 4, 7 for the owner, r plus w, that is 6 for the group, and only read for the others. So like this, okay, we can explain about the permissions, and the chmod is the command to change the permissions of the file. Okay, so this is how we can explain it. Okay, and then we have some other folder commands, okay, where we have seen how to make a directory, okay, and how to change the directories. And once we have done with our work in that particular folder, we can remove that folder. Okay, to remove that folder, we have to ensure there is no file existing in that particular folder. First we have to delete all the files in that particular folder, and then we have to remove the folder. Okay, so let's suppose I am creating one more folder for our practice, folder 2. Okay, so I'm going into folder 2, change directory. Okay, and I'm giving ls, there is no file. I'm just creating a file here, a sample file. Cat sample. Okay, so now I have a file. Okay, now I just wanted to come out of this particular folder, and now I wanted to remove this folder. How to remove the folder? rmdir. How to remove a file? It is rm. Rm is the command to remove the file. Okay, to remove a directory, it is rmdir, the folder name. Okay, it will give you a message that the directory is not empty. Okay, so what to do now? I have to go into the folder, remove this particular file, okay, remove the files. I have given a star so that it will imply for all the files, so it has to remove all the files in that particular location. Okay, now if I say ls, there is no file existing. I have to come out of this folder, and then rmdir folder 2. See, now if I see, folder 2 not existing anymore. So like this, I can use rmdir to remove the folder. Okay, so we can make a directory, we can change a directory, you can remove a directory with the remove command, rmdir. Okay. Okay. So we have seen almost all the useful commands. Okay, we have seen this list of all the commands in all these 3 sessions. Okay, ls, display, more or less, copying, renaming, removing of the files, comparison and differences, okay, make directory and change directory, okay, how to find the word count, how to see the content, okay, how to cut the content, okay, how to combine the commands with the pipe, okay, how to translate one single character to other character. Okay. We have seen head and tail command, the file permissions. Okay, we have seen grep command to search the patterns, compress and uncompress. Okay, we didn't see the tar. It is for the archival purpose. Okay, it is not very much used. Okay, we'll go through this in other time. Okay, file permissions we have seen, rmdir we have seen. Okay, it is rm with a -f switch. It is called forceful removal of the content. The force creation. Okay, sometimes if some other user is open that file, we may not be able to delete that file at that particular moment, but in that particular situation also, if you want to remove that file forcefully, then you can use -f. Okay, so it will remove the files in any circumstances. Okay, but it is very dangerous command. Okay, so you have to be ensuring, okay, before applying this. So I'm not interested to teach you this because it is a dangerous command. With experience you have to get this. Okay, so if you use a -r also, it is recursive. Okay, so if you use this command, it will delete all the structure, the folder structure from the system itself. So don't apply this command, just have it for information that remove -r with f, okay, will delete the entire directory structure also. So it can delete the directories with a -f command and -r command. So it will delete the entire structure of the files and folders from the current location. Okay, and you have seen pwd. Pwd is nothing but to show the present working directory in which you are working in. Okay, so here home folder 1. So let's go out of the folder 1, and if I give present working directory, it will show you in which directory you are presently working. Okay, that is called present working directory. Okay, so it is to change the password. So these are our administrator commands. Okay. No need to go with this. Okay, so it is enough to have a basic knowledge of all these particular commands to tell that we have a basic understanding of Unix commands and we have interaction with the Unix operating system. Okay. So any questions up to here in any of the command? You wanted me to show an example or any scenario for these commands, any one of the commands or any set of the commands?
Sir,
Yeah.
what's the command to clear the screen?
It is CLS, but it is not working here.
Yeah, in my system also it's not working, that's why I'm asking you.
Yeah. Actually, I mean, in DOS also we have, yeah, but here it is not working. I was also trying with CLS. Okay, either CLS or CLEAR, clear. In one of these commands it should work, but in Sigwin it is not working. I'm not sure. Okay, you can note down CLS is for clear screen.
Okay, sir.
Okay. Any other questions? So you able to download it and you able to install it, right?
Yes, sir.
Okay. Fine then. Okay, so this is how you have to practice. You will make your notes and you get a man command also to explore some other switches which I didn't teach, so that you will get habituated to debug. Okay, whenever you get a new requirement, okay, we don't have all the requirements repeated every time, right? So we have to explore and we have to search for the new options. So you just go for the man command, see the switches and apply it. Okay, how to apply the switch on that particular command and explore it, so that you can get more knowledge and more practice. Okay, so thank you very much. Okay, we will meet tomorrow and we will discuss on the basic data warehousing concepts. Okay, if you don't have any questions on the Unix commands after you practice, we will switch to data warehousing concept tomorrow. Okay.
Okay, sir.
Thank you.
Sir, can you
See you
please share yesterday's class?
yesterday's class. Okay.
Yeah.
Yep. Yeah, I will check with them. Actually, I got the third class today.
Okay.
Okay. The fourth class I have to get from them. If I get, I will share it with
Okay, sir. Okay, sir. Thank you.
you. Okay. Thank you. Bye.
Bye.